Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Here we're asked to compare the average binding energy per nucleon of a sodium-23 isotope with a sodium-24 isotope. This problem requires you to look up a number of values in Appendix B, specifically atomic mass values. For the mass of the sodium-23 isotope, it is 22.989769 atomic units. For the sodium-24 isotope, it's 23.990963 atomic mass units. We also need the masses of the hydrogen atom, which includes a proton and an electron. That hydrogen has an atomic mass of 1.009825 atomic mass units. And finally, we also need the mass of a neutron in atomic mass units, and that value is 1.008665. So to find the binding energies of each of these isotopes, we need to find the change in mass from the combined mass of the constituents minus the mass of the assembled atom. And then we divide that change in mass by the total number of nucleons in that atom. So this will be a fractional quantity. We'll draw ourselves a big division symbol here. And we already know in advance that for the sodium-23 isotope, it has an atomic mass number of 23. So its denominator will be 23. We need to find the combined mass of the individual constituents here. We know that there are 11 protons in the sodium atom. And we need to also include the electrons because we're talking about a full atom here in the atomic mass. That's why I'm not multiplying the mass of individual protons here. I'm multiplying by the mass of hydrogen because hydrogen atoms include those electrons that we need to account for. So 11 times the mass of hydrogen plus the mass of 12 neutrons. And we're going to subtract that by the mass of the assembled isotope here. That's M23 Na. And then this whole quantity, in order to get it in units of megaelectron volts, we need to multiply it by 931.5. And that's MeV per U. Doing that, you should come up with an answer of, I got 8.11 3. Well, actually, I got 8.112 here, but it's pretty darn close, so I think we'll keep that. We do the same procedure now for the sodium-24 isotope. Draw ourselves a nice big division line. 24 nucleons in a sodium-24 isotope. We can put that at the bottom real quick. Same number of protons in this compound. So we have 11 masses of hydrogen atoms, but this time there are 13 neutrons. And we're going to subtract that now by a different value for the assembled sodium 24 isotope, and that value is 23.9909. So we'll write it symbolically here as the mass of the sodium 24 isotope. It's doing so well. There we go. Times our conversion factor to electron volts. Recall that each of these we wrote down in terms of atomic mass units. 0.5 MeV over U. Okay. Those numbers come out to, I have 8.063. And I'm sorry, on my last one, I should have had mega electron volts. Always want to remember the units. And we'll box these. We'll call this average mass for 23. And we'll call this the average mass for 24. And again, that was the mass per nucleon. Okay, and that concludes our problem.